Hey, thanks for clicking on the second video. I guess you enjoyed the first video so much that you wanted to click on this video almost as much as you did the first one, but maybe even a little bit more. So in the second video, we're going to talk about how to find least common denominators, because that's one of the most commonly screwed up things by calculus kids when we finally get to the course and all of your algebra simplifications. So we're going to start with some very simple ones, okay, things that involve numbers, and then we're going to work our way on to letters, and we're also going to go back and forth between letters and numbers just so that we can see why things can be simplified and why things can't be simplified. And at the end, hopefully, you'll know how to find the least common denominator. And if you still don't, we'll find out next year when you try to do it on your quiz or test and you don't know how to do it. But you can come see me and I'll help you too. Alright, so let's start with finding least common denominators. Let's start with numbers. I'll teach you how to do it with numbers. I'll teach you how you folks did it with numbers, and then I'm going to show you what I'm going to do in class. So let's begin with a simple one. I moved the video closer so you might actually be able to see what I wrote in this video. If I ask you to add 1/2 and 3/8, okay, you're going to find the least common denominator. The least common denominator is 8. It's the number that goes into both 2 and 8, right? Okay, or it's the smallest number that goes into both. Alright, so the way you guys did it or learned it, I guess, when you were a kid is you had to write it vertically. And your common denominator was 8, so you wanted to make that an 8. You wanted to make that an 8, hopefully. So you multiplied by 4 to get that to be an 8. So you got 4 over 8 plus, you multiplied that by a 1, 3 over 8, and your answer is 7 over 8. Okay? Hopefully that's the way you learned it when you were a kid. I'm assuming it probably is. Alright? Now, here's what I'm going to show you to do. Alright? The way I add 1/2 and 3/8 is as follows. Okay? I skip the middle step where you write it vertically and you write what you multiply by. Alright? That is technically the correct algebraic way to do it, but I skip this step only because we're in calculus and at this point you really should know the algebra and understand it. Alright? And it helps you get to the answer faster, which we're trying to get to. The less steps you need, the easier it is to get to the answer, which is better because less of a chance you're going to make a mistake. Alright? So, the common denominator is 8, so I'm going to write the whole thing over 8. Okay, the first term was a 1 in the numerator, but I need to multiply by 4 to make this 2 and 8. Okay, plus, the second fraction had a 3 there, and its denominator already is the least common denominator, so I multiply by 1 to keep it the same. Alright, and then that gives me 7 over 8. Okay, now let's see how that's done algebraically. Alright, algebraically it's actually a little bit easier than it is using the numbers. So, if I ask you to take 3 over x and add 5 over x cubed, the least common denominator is x cubed. Do we agree? Okay, well, if you don't, it's the largest thing, right, that both of them go into. Alright, first thing that they have in common, that you can multiply and end up with the same. So, the least common denominator is x cubed. The first term had a 3 in its numerator. To get from x to x cubed, you have to multiply by x squared. So that'll be a 3x squared on the first fraction. Plus, leave the 5 from the numerator here. This was an x cubed, it's still an x cubed, multiplied by 1. So you get 3x squared plus 5 over x cubed. And that's the least common denominator, and that's the simplified fraction, okay, added together. Alright, so, let me erase this couple here, and we're going to try to make them a little bit more interesting. And we're going to go from there. Alright, so, hopefully you're having a good summer. I guess you are, I don't really know. Because I can't actually see you. You can see me, but I can't see you. But hopefully. And if you're not, well, don't worry. School's going to start soon. Alright, so let's try 5 over x plus 3 over x plus 2. Okay, the least common denominator is both the terms, or the product of both the terms. X times x plus 2. These are different terms. You need to take them both in the least common denominator. Okay, if you're wondering why, or why your LCD isn't just x plus 2, put a number in for x. Anything you want other than 2. 2 is the only number that wouldn't work. But any other number like 7. If you put a 7 in here, you have 5/7 plus 3 over 9. Okay? 5 over 7 plus 3 over 9. Alright, so now if you wanted to add 5 over 7 plus 3 over 9, okay, if you didn't reduce this 3 over 9, 63 would be your common denominator. You have to multiply both of these. Right? Or a number like 11. So 5 over 11 plus 3 over 13. So your least common denominator is going to be 143, which is 11 times 13. Alright? So you have to take both, the product of the two, okay, because they are not the same. Alright, so now your least common denominator is x times x plus 2. So there's your denominator, x times x plus 2. First term started with a 5 in it. Okay? It already has an x on the bottom. It needs an x plus 2, though, to make the common denominator. So you're going to multiply the 5 by an x plus 2. Plus the 3 from the second term. It already has an x plus 2 in its denominator, but it's short the x. That's here, so you have to multiply that by x. Now you're going to have to distribute and clean this up, and you get 5x plus 10 plus 3x over x plus 2, which is 8x plus 10 over x plus 2. And now there's a common denominator, or GCF, not a common denominator. 8x plus 10, it's a 2. You're going to have to take the 2 out of there, and you get 4x plus 5 over x plus 2. And that would be the choice that you'd see on the exam. Okay? So it's one thing to understand how to get the calculus to get you here. Alright? That's one thing. But you have to be able to take here and get to here. Because otherwise, you're not going to know which choice is the correct answer. Alright? Alright, so what I'd like you to do is I'd like you to try a couple here real fast. I want you to simplify, let's try 4 over x squared minus 3 over x plus 5, I guess. Try that one. Okay, so you're going to hit pause, and then when you hit unpause, you're going to see me do the problem, and hopefully you did it right. And hopefully you can actually see the problem. Okay, not like the last video where you probably couldn't actually see what I was doing. But hopefully you could hear me. I'm a big talker, I talk a lot, so I'm sure you'll be able to at least hear me on that video. Alright, I know you can, because I already watched it. And I tell you what, I did a good job. Alright, so, you hit pause, did you do it? That's a bell, okay? Still here in school? Be cool, stay in school. Alright, so, the least common denominator here is x squared times x plus 5. So, if I do it my way, okay, you can do it your way if you want. Alright, I prefer to do it the way that I always do it, but I mean, you can do it vertically if you want. If it makes it easier for you, you can. Alright, so now your first term had a 4 there in its numerator, so it stays. It already has an x squared in its denominator, but it's missing the x plus 5. So you're going to have to multiply the 4 by x plus 5. Minus 3. It had in its denominator an x plus 5. It needs the x squared to make the full common denominator. So you need an x squared there. You distribute, and you clean it up. And the denominator is x squared, x plus 5. The numerator becomes negative 3x squared plus 4x plus 20. You may leave the leading term as a negative. Okay, you may leave the leading term as a negative. You do allow that. Only if all of these are negative would you have to take the negative out. Alright, it's not wrong to take the negative out, but it's not necessary to do so. Okay, so hopefully you got this. If you didn't, there's plenty more problems you can practice on the internet. So try to practice, or watch the video again. Maybe you don't get it. Alright, watch the video again. Because nothing says fun like watching a video with me on it. Alright, over your summer, you know? I don't think it gets any better than that. Well, at least me personally. Alright? Okay, so now the other thing that we need to be able to do is you need to be able to simplify complex fractions. Alright, this gives kids the worst problems, even worse than common denominators. So, If I ask you to simplify a complex fraction, let's simplify, well, I tell you what, let's simplify this. Let's try 1/2 plus 3/4 over 5. Okay? If you were asked to do this, I hope the first thing that you would do would be to add the 1/2 and the 3/4. Alright? That should be the first thing that you do. So if you add the 1/2 and the 3/4 and leave the 5 underneath, right, leave the 5 where it's at. So you're going to get one fraction in the numerator when we're done. The common denominator is an 8. Alright, so the first term has a 1. You have to multiply it by, or the denominator by 4 to make 8. Plus, the second term is a 3 in the numerator. You want an 8 in the denominator, multiply by 2. And you get 10 over 8 over 5. Now the question is, how do you simplify that? Well, you could simplify the 10 over 8 to 5 over 4 if you want. I'm not going to, but you could. Okay? So the question is, now what? Alright. What most people do is they say, okay, now I multiply by 1/5 on the top and the bottom. That's correct. Most of you don't know why you do it, but you do it. Alright? This 5, okay, doesn't just randomly belong here. There's a reason for it belonging here. So, let me show you why. Here's an aside, I call it. Okay, an aside is something that, is relevant to this problem, but, it's a different concept or a completely different problem. All right, but it is relevant here. So, as an aside, if I asked you to take 8 and divide by 2, you would tell me that's 4, I hope. If you don't, then we got real issues, but hopefully you're going with 4. Now, I know you all know that. The question is, isn't that the same thing as what I just did? 8 over 2 and 8 divided by 2? They're the same thing. So this is also 4. So then, based on this aside, 8 divided by 2 is the same as 8 division sign 2, like it was in the 4th grade. Doesn't this mean take 10 over 8 and divide by 5? It absolutely does. It's take this fraction and divide by this number. So how do you do this? Well, you all should know how to do this. It's 10 over 8 times 1/5, right? You multiply by the reciprocal. You can cross-cancel if you want, whatever makes you happy. You get 10/40ths, which is 1/4. And that's the correct answer. That's why, in this step here, over 5, you say, okay, I multiply by 1/5 in the numerator and the denominator. You're multiplying by 1 here. That's what this is. You're multiplying by 1. All right? This is a shorthand version of it. This is how you learned it to begin with. All right? But here you're multiplying by 1. 1/5 divided by 1/5. So these go away, and then you're left with the same problem that we had up here. All right? That's how you simplify a complex fraction numerically. Now, if it's algebraic, it makes it slightly more complicated. So, if I ask you to simplify 1 over x, make it 1 over 3. 1 over 3 plus 1 over x plus 3 all over x plus 3. Alright, this is no different than with doing it with the numbers. Okay? We need to simplify these fractions. You need to add them in the numerator so that you get only one fraction. Well, the common denominator in the numerator is 3 times x plus 3. So you want to make this denominator in the numerator a 3 times x plus 3. The first term had a 1 to start. It already has the 3, so it needs the x plus 3. Plus, there's a 1 here, already has an x plus 3, needs a 3. So the denominator stays the same as x plus 3. In the numerator, there's a fraction. That fraction is x plus 6 over 3 times x plus 3. Okay? There's your fraction in the numerator. Alright, now what do I do? Take this fraction and divide by this quantity. So take this fraction and divide by this quantity. So that means this, x plus 6 over 3 times x plus 3 times 1 over x plus 3, the reciprocal. And that'll give me x plus 6 over 3 times x plus 3 squared. Do we agree? The bases are the same, so you add their exponents. This has a 1 on top, this has a 1 on top. Add them together, you get 2. It's the opposite of doing GCFs like we did in the first video. Hopefully you already watched the first video. If you didn't, go back and watch it, because it's a great video. Really fun. You really can't see what I'm doing up there, but hey, you'll get over it. Alright? And that would be a simplified answer. Okay? We're going to talk a lot more about complex fractions when we get back. Alright? Especially simplifying them. What can you simplify? What can't you simplify? Why can't you, reduce things or cancel things? Alright? Why don't they reduce properly? Okay? We're going to talk a lot more about that when we get back. Alright? And you're really going to, this year, I hope, really going to understand a lot of the algebra that you've learned over the last few years. As opposed to where it comes from, and not just doing it just to do it. Alright? Alright, so now what I want you to do is I would like you to try this one, give it a shot. Let's try, and make it a 2. 2 over 5 minus 3 over x minus 5, all over x minus 5. I'd like you to try to simplify that one. Okay, so you're going to hit pause, remember? Remember what you do? You hit pause. Okay, and then you simplify it, and then when you're done, you push play, and then you're going to watch me do it. All right, ready? You push pause, and then I'm going to do it. All right, here we go. So, in the numerator, the least common denominator is 5 times the quantity x minus 5. So in the denominator, you want a 5 times x minus 5, okay, for that fraction. The first term had a 2 in it, and it needs the x minus 5. Minus, the second term had an x minus 5, or no, a 3 in it, sorry. 3 in it. And then it needs the 5. Alright, so now, if you clean that up, you have x minus 5 in the denominator. In the fraction, you have 5x minus 5 in the denominator. And in the numerator, if you distribute and clean it up, you get 2x minus 25. Okay? So now this is 2x minus 25 over 5 times x minus 5 divided by x minus 5. That's 2x minus 25 over 5 times x minus 5 times 1 over x minus 5, which will give me a result of 2x minus 25 over 5 x minus 5 squared. And that would be the correct answer for full credit. Okay? You have to be able to simplify complex fractions. I really don't know if you can see me in the screen right now because I think I'm pretty close to the end and I can't actually see myself on the iPad. All I can see is the little apple that somebody ate part of. That's about it. So if you can't see me, it's kind of creepy. But if you can, that's good. Or if you can see half of me, it's a little weird but fun. Alright? Well, that's it for this summer. Okay? I do expect you to understand these concepts or at least know how to do them when you get back. Alright? Because I don't want to waste a lot of time going over these again, especially since I did make these exciting, fun videos for you to watch. Okay? If you do have questions, though, come see me and I will help you. Alright? Don't come see me over the summer. That would be creepy if you showed up at my house. Alright? But when we get back to school, come and see me. I will help you. Okay? And we'll talk a lot more about why things, especially the reducing part, why things will reduce, when they won't reduce, and things like that when it comes time when we get into class. Alright? But these are 2 basic algebra skills that you really have to have to be successful here. Okay? So, good work. Thanks for coming. If you still don't get it, watch the video again, because, what can I say? It's fun to watch me on videos, I guess. I don't know. Alright, good talk. Bye for now.